in an exam what happened, there were three people, for example student A, student B and student C. The student A has got 20 out of 100 and student B has got 40 out of 100 and student C has got 80 out of 100. All right. So these are the marks which are scored by these three students. Now, whatever this 20 marks are scored by this person A, right, or a student A, so these marks are called as absolute marks of student A, these 20 marks. All right. And these 40 marks are there, no, so these are called as absolute marks of student B, and whatever 80 marks are scored by the student C, so these are called as the absolute marks. So 20, 40 and 80 are called as absolute marks, absolute marks of A, B and C respectively. All right. But now they want to compare with each other. For example, B wants to compare. B compared with A. When B compared with A, the B will become very happy by thinking that I have scored double the marks. Look at this, double. Okay, so, A has scored 20 marks and I have scored 40 marks. Then when B compared with A, he feels like he scored double the marks, all right. I hope the concept is getting clear. Now when B compares with A, so look at this, B compared with A, B is comparing with A means he will get half the mark. Okay, whenever B is comparing with A, how many marks he got? He got half the marks. Are you understanding this point? So whenever absolutely they are working with the things, there is no doubt about that. Whatever they have got, that is their absolute marks. But whenever they are comparing, so this doubled, this half, so that brings us to a concept like relative marks. What is the name of the concept, dear young minds? The concept is relative. The relative concept is very, very important in physics. All right. So what is the meaning of relative? Now look at this. If a person A is compared with C, for example, A is compared with C means, look at this, A is getting compared with C means C has got 80 but A has got 20. That means whenever I compare A with C, that means how many marks the A got? 1/4 marks. 1/4 marks. Are you understanding my point? So whatever this 1/4, 1/2 or 2 times 1 by 2 times, so all these are the relative words, so which brings us to the gravitation 10th video, and in this we are going to discuss about absolute density and relative density. My name is Shrikant Bashetti. I welcome all of you to your beautiful physics channel, PhysicsPoint, and let us try to understand what are these absolute density and relative density formulae and concept. Let's get started. Now, what is the meaning of this absolute density of a material? Absolute density is nothing but just density. You can just call it as density also. All right. So the symbol for density is rho. Now, if you don't know what is density, then go back to the previous videos and learn about that. Now you can go back to the 9th video and you can study in detail about density. Just to give you a simple idea, the density means that density is equal to mass divided by volume. You know about this, mass divided by volume. Now, how much mass? I mean, unit, if you go for the unit will be kg per meter cube. Kg per meter cube. All right. There is a container, for example. In this container, you are keeping material A. You are filling material A. You have filled material A. Okay, in this space. Okay, in this volume you are filling the material A. For example, the volume of this material is like 1 meter cube, and mass whatever you have filled is like, for example, 100 kg of material you have filled, means the density of material A, rho A means density of the material A will be mass divided by volume, so that becomes 1000, not 1000, 100 kg per meter cube. So this is only known as what? This is known as absolute density of material A. Absolute density of A, or you can skip this word absolute and you can just call it as a density of material A. I hope it is clear. Now let us take one more container. Okay, same container. Let us take this volume to be 1 meter cube, or you can take it as 2 meter cube, no problem. Now you have filled some other material here. Okay, so let us call this material as a material B. All right, so the mass what you have filled here is for example it is 100 kg again, just an example. Okay, now what is the density of this material? Let me call it as rho B. What is the meaning of this rho B? Rho B means it is the density of material B, or absolute density of material B. So it becomes 100 divided by 2 and the answer will be 50 kg per meter cube. Alright, so this is the absolute density. Now if you want to compare this A and B, look at this A and B. A is 100 and B is 50. Now if you want to compare both of these, compared to this is doubled, and compared to this is half. Alright, I hope the concept is quite clear. So that brings us to the concept of relative density. Now let me make it very clear to you. What is the meaning of absolute density? Absolute density means just find out the density of that material. Okay, how much mass it is there in the given volume, then it will give a absolute density. Now if you come to relative density means it has very simple definition, that is density of a material density of a material with respect to another material So what is that another material? That another material can be water, or it can be mercury. Okay, it can be mercury, or it can be anything else. So any matter, usually we take liquids here. So just an example I have given you. So density of a material with respect to another material, by comparing it with another material, what is coming? That is known as relative. See, just to give you idea about relative things, the people got 20 out of 100 and 40 out of 100 and 80 out of 100. No, so what are these 20, 40 and 80? These are the absolute marks. We are not comparing with anything. I mean, we are comparing with 100, that is there, but this is the standard benchmark, right? No, so we are comparing that with 100, 100, 100, that is there, but this is a normal benchmark for everyone. So this is a benchmark for everyone. So they have got 20 out of 100. This is compared to 100, so they have got 20 percentage, that we know, and here they got 40 percentage, we know that. Here they got 80 percentage. So what are these? So these are their absolute things. These are the absolute marks. These are the absolute percentages. Now if you are comparing like this, so this becomes double the marks. Now if you compare here, it becomes again double the marks. If you go in the reverse way, it becomes half. Are you understanding my point, what I am trying to say? Here this person who has scored 80 has scored 100 percentage more marks than the 40 percentage person. 40 to double means he scored almost 100% more, no? Alright, so that is the relative concept. We have to compare any two quantities, this or this, this or this. Okay, let me give you the definition properly. The relative density, for example, I have material A. Okay, I have material A. So this material A is having absolute density rho A. So what is this rho A? Rho A is nothing but absolute density of A. Absolute density of A. Alright, and I have another material. That material is like B. So that material is B and it is having density rho B, and this is the absolute density of B, material B. Absolute density of material B. Now if I want to find out relative density, relative density of material A, with respect to B means it is represented with rho AB. So what is the meaning of rho AB? Rho A is known. This is absolute density of material A. Rho B is known. This is absolute density of material B. Already I have written that. But if I write rho AB, so what is the meaning of that? That is relative density of material A with respect to material B. The formula is absolute density of material A with respect to absolute density of material B. So absolute density of any material, the relative density of any material with respect to another material is equal to absolute density of the first material divided by absolute density of the second material. So this is the formula which you have to remember. For example, if I am writing rho CD, what is the meaning of rho CD? Rho CD means relative density of material C with respect to material D. So that becomes rho C divided by rho D. Alright, if I write rho xy, what is the meaning of rho xy? Relative density of material x with respect to material y. So it becomes rho x divided by rho y. Similarly, if I write rho yx, what is the meaning of rho yx? Rho yx is relative density of material y with respect to material x, and the formula becomes rho y divided by rho x. Alright, please remember this formula. And coming to unit of relative density. What is the unit of relative density? The unit of relative density is unitless. I mean unitless as in it has no unit. Look at this. This is also kg per meter cube. This is also kg per meter cube. Both will cancel. So that's why it comes under the category of quantity with no unit. It is unitless. Okay, if they ask you one question, tick the odd one. Tick the odd one. Okay, odd one, and they gave you some quantities like one is force, okay, second one is mass, and third one is velocity, and fourth one is relative density. Now which one will you take out? Relative density. Just to give you some more idea, so instead of this velocity, so let me give you density here. Which one will you take out? Take the odd one, which is not fitting in this combination. Take the odd one. So what is the answer for this? This is relative density. Why? Force has unit Newton, mass has unit kg, density has unit kg per meter cube, but this has no unit. Alright, so all these are the quantities with units. This is not having any unit, so that's why you have to take this. Alright, coming back to the main point, why this relative density is very important. Why relative density is important? Alright, there are so many materials, right? So why this concept has become important? Let us see. For example, if you take some materials will be sinking in water, right? Some material, they sink in water. Okay, let me write it completely here so that you understand it. Some material sink in water. Sink in water. Why? If I ask you why they are sinking in water, the answer is quite simple. Density of that material should be less, not less than, it is greater than. Density of a material should be greater than density of water, then they are going to sink. Alright, and another thing, some material float in water. What is the reason for this? The reason for this is the density of that material should be less than the density of water, then they are going to float. Alright, I hope you know this in the Archimedes principle, and in some other concept of buoyancy and all. I have talked about this, why some things will be floating and why some things will be sinking. Now, what is the relation between this relative density? With the help of numerical also we can understand it, but let us try to understand. Before the numerical, let us try to get it. We have one material A. For example. Okay, it is having density, absolute density, let us take it as a 1500 kg per meter cube. Now tell me, will it sink or will it float? It is going to sink, right? Why? Because density of water is what? Density of water is 1000 kg per meter cube. This is fixed, right? So water is having 1000 kg per meter cube, but this material is having 1500 kg per meter cube, means it is more density. That's why it is going to sink. Now, if you find out the value of rho AW, what is the meaning of rho AW? Rho AW is relative density of material A with respect to water. So, if you do this, what will be the answer? The answer is like rho A divided by rho W, and rho A is 1500 and rho W is 1000, and 0, 0, 0, 0, it get cancelled. What is the answer we are getting? We are getting 1.5. This is first case. Alright. Now, if you take material B, let us take one more material. Okay, material B, and this is having a density, absolute density as a 900 kg per meter cube. Just an example, okay, 900 kg per meter cube. And what is the density of water? You know that already. Now, if I want to find out relative density of material B with respect to water, what is the formula here? It becomes rho B divided by rho W. Alright, so what is rho B? Rho B is nothing but 900. Rho W is 1000. Now 0, 0, 0, 0, they will get cancelled, and you are getting it as 0.9. Now look at this, what will happen to this material? This material will float or not? Why it is going to float? Because its density is less than the density of water. How about this material A? So this is going to sink. Why it is going to sink? Because its density is more than the density of water. Now come here. Now this material A is having relative density greater than 1. And how about this, material B is having relative density which is less than 1. Alright, the materials which are having relative density is greater than 1, they are going to sink. Very, very important concept. The materials which have relative density less than 1, so they are going to float. Okay, if I ask you, there is one material with respect to water, I have find out its relative density. It got relative density as 2. Will it sink or float? Definitely it is going to sink. Look at this. Make notes, make proper notes. I know that the things are getting clumsy here, but the concept is quite clear. Alright, so step by step you have to make the notes. Now, if I say the relative density of a material with respect to water is 0.5, will it sink or float? Definitely it is going to float. This is the main use of relative density. What is the meaning of relative density of a material is 2? That means it is 2 times of water. 2 times of water means 1000 is there. The density of this material will be 2000. And what is the meaning of saying the density, the relative density of a material with respect to water is 0.5? The meaning of saying this is it is 0.5 times of 1000. 0.5 times of 1000 means it becomes 500. Alright, so let me go to the next page, and before solving this problem, let me tell you, if I say relative density of a material, relative density of material X with respect to water is equal to 4 means, if they ask you what is rho X, what is the meaning of rho X? The meaning of rho X is absolute density of material X. Now, relative density of material X with respect to water is how much? 4. That means absolute density is going to be 4 times. 4 times of water, that means 4000. 4 times of water means what? 4 into, so 4 times of water is like, into 1000. So, it becomes what? 4000 kg per meter cube. So, the relative density value has to be remembered. Instead of remembering this 4000 kg per meter cube, we have to remember this relative density concept. Alright, so if I say relative density of material Y with respect to water is equal to 1.5. Now, what will be the value of absolute density of material Y? Tell me. It is going to be 1.5 into 1000. So, 1.5 into 1000 means it becomes 1500 kg per meter cube. That's it. That was the main concept. Alright, please make a note of this and let us go to the numericals section, and let us solve some numericals. Please pause the video and make notes of all these things, whatever I have written, because I am rubbing them off. Pause the video and make notes on this. Now start to read that question, those who have made notes already. What is the question here? The question goes like this. Density of a material is 2000 kg per meter cube. So density of a material means what? Rho m. Rho m is equal to what? This is 2000 kg per meter cube. Alright. Now find its relative density with respect to water, and density of water is given. So density of water is like 1000 kg per meter cube. Now what they are asking? They are asking relative density of this material with respect to water. You know the formula, that is rho m divided by rho w. Alright, so if you carry forward this calculation, so it becomes rho m means what? 2000, and it is 1000. So here 3 zeros and here 3 zeros will get cancelled and get the answer rho mw. So what is the meaning of rho mw? Relative density of material m or any material with respect to water is 2 means what will be its absolute density? Tell me. 2 into 1000. So 2 into 1000 is 2000. Look at this, we got the same answer here. This is not a part of the solution, okay? Just now I have told you, I explained one concept, no? Just to clarify, I told you. Let's move to next question. So what is this? Density means again absolute density only. Please remember that density of material A is 200 kg per meter cube. That is like rho A, material A, right? So rho A is equal to 200 kg per meter cube. And density of material B is 500 kg per meter cube. That is like density of material B is 500 kg per meter cube. Now they are asking find relative density of material A with respect to material B, that is rho AB. Rho AB is equal to question mark. Now what is the formula for rho AB? So rho AB is equal to rho A divided by rho B. What is the value of rho A? Rho A is 200 and rho B is 500. 0, 0, 0, 0 cancel. So what is the answer coming here? 2 by 5. 2 by 5 means 5 ones are 5, 0.4. So 1 0 we take here and 4s are, and this value is 0.4. Alright, so relative density of material A with respect to material B is 0.4. If they are asking relative density of material B with respect to material A, so then the formula would have become rho B divided by rho A. Just extra I am telling you. Okay, the solution is over there. So rho B means what? Rho B is 500 and this is 200. So 0, 0, 0, 0 get cancelled. 5 by 2 means it becomes 2.5. Relative means not only with respect to water, it can be with anything. Here we got with respect to water, but you can compare any material with another material. Alright, so let's move forward and let us take this example. Now look at this nail. This nail is there, no? This nail is sinking in water. Why this nail is sinking in water? Definitely relative density of nail with respect to water, whatever we get this value, this must be greater than 1. This must be greater than 1. That's what I told you in the previous section. If you want to confirm, you can confirm this. What will be the density of this nail? The density of this nail should be greater than a density of water, that is for sure. Correct, no? Are you getting my point? That's why it is sinking, no? So density of the nail is greater than density of water. So if you want to find out relative density of nail, otherwise you write it symbolically so that you understand in a better way. Relative density of nail with respect to water. Okay, what is the formula here? The formula will be absolute density of nail divided by absolute density of water. Correct, no? Now this nail is having more density. Look at this. This is having more density. This is having more value. This is more value. This is less value, means I should be getting this as greater than 1. Correct, no? What I am trying to say here is if any material is there, any material it may be, if you compare it with water, if you compare its density with water, and if you are getting the value greater than 1 means definitely it will be sinking. Correct, no? Moving forward, now look at this cork. Look at this cork. This cork is floating, no? Why it is floating? The answer is quite simple. That is like relative density of this cork with respect to water should be less than 1. If you are comparing any material, it may be any material, here it is cork, okay? You are comparing this cork with water and you got the relative density as less than 1 means it will definitely float. And if you are getting this value greater than 1 means it will sink. Okay, why stone is sinking? If you take any stone, that stone will sink in water, no? It will sink in water. Why that stone will be sinking in water? Because relative density of that stone with respect to water, you can write it symbolically, relative density of that stone with respect to water should be greater than 1. If it is greater than 1, then it is going to sink. I hope you'll remember this concept moving forward. Now look at this interesting example. I have chosen this for you guys. Now this guy, observe this video very carefully. So this guy is taking this nail towards mercury. Look here, this is a mercury side, no? So he is taking it towards the mercury side. When he throw the mercury, he throw this nail in mercury. Whenever he has thrown in mercury, now this guy is taking this nail towards water. Okay, this nail towards water, you have seen that nail towards water. What is happening? Just observe in both the things. Now he is taking towards mercury. Now observe this carefully. So if this he is taking towards mercury means that this nail is going to float here. This nail is floating. Now whenever he is taking it towards water, what is happening to this nail? This nail is sinking. This nail is sinking. What are the reason for this? What are the reasons? You can give many reasons for this. Please observe this concept very carefully. Very carefully, then only you will get the real feel of this relative density concept. Now leave that video, leave that gif there and concentrate here. The nail in water is sinking means the density of the nail should be greater than density of water, first thing. And relative density of this nail, or you can just write it as rho. So relative density of this nail with respect to water should be greater than 1. Correct, no? So if you are comparing this nail with water in terms of density, and if you are getting it is greater than 1 means it is going to sink. Correct, no? Now observe this, the nail is floating. What does it mean? It means the density of this nail, the density of nail should be less than the density of mercury. Please observe this. Okay, the density of the nail should be smaller than the density of mercury. That's why it is going to float. Or in other words, you can say the relative density of this nail with respect to mercury. Okay, M means mercury. Usually the symbol is Hg. Hg is the symbol for mercury. Okay, I will come to that in the chemistry section. The relative density of nail with respect to mercury should be less than 1. Whenever you are finding out relative density of any material with respect to another liquid, if you are getting it as less than 1 means definitely it is going to float. And if you are getting greater than 1, it is going to sink. This is the main concept. Alright, I hope the concepts are quite clear and you got to know about relative density. Just to summarize the things, let me summarize the things in here. Okay, already I have asked you to like, share and subscribe, but still the concepts are not yet over. Let me explain here. If density of a material is greater than density of water means what will happen to that? That will sink. That means relative density of that material with respect to water is greater than 1. Alright, this is there. And second thing is, if density of any material is less than the density of water means it is going to float. And the relative density of this material with respect to water should be less than 1. So this was the main thing what I wanted to tell. Alright, then make it sure that you are liking these videos, sharing these videos and subscribe to the channel. That's how the YouTube gets to know that these videos are good and have to be recommended for other people. Alright, then thank you very much. Have a good day and bye-bye.